All right. Here there's this quick review. So this is what I do usually on my free time. I got this laptop from someone who wanted me to fix for them. So this computer is actually dead, has no power, does not respond anyway. Even if you remove the battery, the computer does not respond. Even if you drain the board, the computer does not respond. So usually, as a technician, the first troubleshoot is the power adapter. So first, I tested the power adapter is just functioning well, and the output is just fine. You know, this is a Lenovo ThinkPad Yoga 370. So you know, usually Lenovo uses 20 volts, if not 19.5. So the main area where the power lines is here. So this is a port on the board of the computer. So the power lands here. So I wanted to check where the power uh, stops or where there's a bend or breakage. So the first power lands here. We are not concentrating on negative or eighth, but we are focusing on the positive. So um, let me use the layman's language here. So the positive will land on these three pins. So these three pins will receive the power from here. So the power moves here to the first component, which is known as a fuse. This is the main fuse, has a high resistance. So the fuse is just fine. I tested it using multimeter. So the power continue as it goes to the next component. Before it goes to the next component, there's a small component there, um, which is a capacitor. So the capacitor is just working well. So we continue with the power to the first component. This is the main component because always on the laptops there are two MOSFETs. The first MOSFET um, is this one. So usually the MOSFET has three components. The first component is source. So the source where there is the power lines is coming from. So um, then we have the drain where the power comes out. So um, we have again the this is it, our drain going to the next MOSFET. But we have another component which is number three, which is the gate. So the MOSFET always has three component gate. So for instance, assuming that we have this power supply company that supply the electricity to the houses. So usually they use transformers as step downs. So they step down the main power. For instance, if the house receives 100 volts, so what transformer act is that it steps down the main power to 100 volts to supply to a specific house. So if that house, okay, assuming that it's a maize meal, so maize meal or it is maybe last meal. So usually you find that um, the transformer, the cable that will come from transformer to go into that maize mill, they will usually use two cable to double the power on that maize mill. So this is what is happening. So the MOSFET receive the power from the fuse. So here, once it receives the fuse, it has three component. The first component is source, the second one is drain, and the third one is gate. The gate is it is measured in usually it has 3.3 volts or it has 5 volts. So this 3.3 or 5 volts, it means that it depends with which component it requires at what amount of current. So that's what we are saying here. If that component, for instance, a keyboard, it requires 3.3, then mean that there will be a diversion of 3.3 toward that keyboard. So that's what we are saying here. It's just simple. The next thing is we have the second um, MOSFET. The second MOSFET just act the same way with the first one. The second MOSFET is it has the source, it has the drain, and it has a gate. So I tested this. The first MOSFET is just working properly. It's just good. The second MOSFET, uh, at the source, there is 19.5. Remember, always Lenovo uses 19.5 or 20 volts. So even 19, that's just okay. So the source has 19. The gate is just fine. It's 3.3. So while the drain um, has nothing. The drain, there's none here. There is none here. So mean that there is no power that is coming from this MOSFET going to the main resistor. This is, remember, this is our first resistor here. So there's no power that is going to this resistor. So since there is no power that is going to this resistor, where we are going, we are not going to the processor, or we are not going to a central component. This movement is going toward the main IC, which is known as a power control unit. But here, the power does not pass. It stops on this MOSFET, meaning that this MOSFET is down, is dead, has to be repressed. So if we press this component, this MOSFET, will have the power going direct to this to this resistor. So we have the power direct going to this resistor. So here, mean that it will allow us to have the power to the next component, which will be a main IC. Now, this is what I wanted to explain. It's just a movement where we are tracking the power flow using the power layer, the first power layer on the board. So yeah, usually this is what usually on the board we focus on the three powers. The first main power is 19 volts. The second one is 5 volts. The third one is 3.3. So this small volts depends where the power is going, but the main one we wanted to focus first on the main power. So in short, here, in conclusion, here we are saying that uh, the second MOSFET is dead, has to be replaced as soon as possible to fix the whole computer. So once this one is fixed, we'll find that the whole computer to be powered. Yeah, this is what I wanted to explain. Remember, on the computer board, we always have circuits, like multiple circuits. So this circuits works independently, connecting from one to another. So if this circuit of power supply circuit is dead, mean that this is dead. It is not supplying anything to the next circuit. So on each and every circuit, there should be an inductor. Remember, an inductor is a coil that represents a circuit. So yeah, this is what I wanted to explain. Thank you so much.